I'm David Barroso. I'm the Associate Director of the Telescope Makers Workshop in Oakland.
Can you tell us more about how to make telescopes?
I can give you a little idea. Telescope making is something that anybody can do. It has a long pedigree. It goes back to Isaac Newton, who did the first reflector, and what you're seeing here on the table and over there on the stands are basically reflecting telescopes. This one right here being a 11-inch, we rate these mirrors in size of diameter. So we measure the diameter across the mirror. This one's an 11-inch. The one over there is a 20-inch. You can see here, Jack has turned it over. This is the grinding tool. When you do a reflecting telescope, you have basically two components. You have the piece of glass, and you have the tool that shapes the glass. We call this a tool, a grinding tool, and we use various grits. We start with a real coarse grit, and we move on up to a very fine grit. When we're done grinding, we go to a polishing stage, and the glass is polished, which again, you can see this big one over here kind of reflecting, which because it's been polished. The test rig that we have here, and this is a tester. This unit right here is how we tell when the glass is complete. If you're going to do a piece of glass, of course, you want to know when you're done. So this has a light source. It shines a beam of the light to the glass. The glass reflects the light back through your tester, and we look at the image. If we could take the camera here and actually put it right here behind the tester, you would see a piece of glass down there that has a green image and has straight lines across it. Now, if the lines were anything but straight, I'd be a failure. I hadn't done my job right. But the fact that if you look right here, you'll see that there are straight lines across that glass. It's very important for us at this stage that glass be spherical. If it's not spherical, we've wasted our time. So the big piece of glass that you're looking at down there is in the process of being polished out. Okay, polishing the glass out is just getting it into a polished spherical condition. After it's spherical, we have to go ahead and parabolize it, which actually makes it into a complete, perfectly reflecting telescope. These things are all done every Friday night at the Telescope Makers Workshop in Oakland at the Chabot Science Center. The time that it takes to do these mirrors is remarkably constant. It's not so much the time, it's the size and the weight of the mirror. A smaller mirror, you can do one, and we have a standard figure of about 40 hours it takes to do an average mirror. The only difference you get on a big mirror like this is it gets heavier. So but as far as the actual time it takes to grind it, it's by and large about in the same ballpark. So if you want to work on a mirror like this every day for 8 hours, you probably could finish it in about 2 weeks. So it's not as bad as it looks. It's just the bigger they get, the heavier they get.
I'm Jane Houston Jones, and I'm the former president of the Astronomical Association, Northern California. And if I was still here, I'd be president, but now I work at JPL in Pasadena.
Okay, what do you do at JPL?
I do education and public outreach for the mission to Saturn, the Cassini mission to Saturn. So I go to Saturn every day for work.
Is the Cassini mission still going on?
We're in the 4th year of a 4-year mission. We've been at Saturn for almost 4 years now, and we're expecting to have a 2-year extended mission, although it hasn't been formally approved yet. The spacecraft sends back amazing pictures of Saturn and the moons of Saturn, almost every day.
Okay, and also, what is the AANC?
Astronomical Association of Northern California. It's an umbrella group of, about 20 astronomy clubs and many science centers and planetariums, all in the greater Northern California area. And meetings like this are their kind of get-together where members from all those different clubs get to come together and see what they look like in the daytime. There's also quasi or professional amateur organizations that are members, like the ALPO, which is the Association of Lunar and Planetary Observers, and those are the two of the members right there. There's meteor observing folks here that gather amateur astronomers and professional astronomers together to do science. And all of us kind of come together at these meetings and share our excitement about astronomy.
Well, I'm Marty Berenson, and I'm here with Vivian White from the Astronomical Society of the Pacific. And we are here at the AANC Convention, sharing some of the activities that have been developed for several of our educational programs, like Project Astro, Night Sky Network, and Family Astro. Our mission is to improve science literacy through astronomy education, and that's what we've been doing since 1889, so we're a cause-based organization.
Hi, I'm Vivian White, and I work with the Astronomical Society of the Pacific. I train teachers how to work in the classroom doing astronomy with an amateur astronomer partner. So it's through a program called Project Astro. And these are some of the activities that we do in that program.
What kind of activities do you do?
Lots of scale models of the solar system, especially for grades 3 and 8, where it's in the standards, 3, 5, and 8, where it's in the standards. And we do stellar evolution. Today we've made a planet walk, so there's a scale model of the solar system to the size of a 1-meter sun. If the sun were 1 meter, how far away and how big would the planets be? We only made it out to Mars, because after that, yeah, it goes down the hallway.
Actually outside.
Outside,
Right.
Yeah. So that's one of the things we're doing. What else are we doing? We're making worlds in comparison, so scale models of the planets in the solar system with Play-Doh. We have one Marnie just showed you with the pocket solar system. And we do eclipses, how eclipses are made, distances between the Earth and Moon, for example, things like that.